Alrighty, thank you everyone for joining us today. My name is Joss. I am a public health major here at UC Berkeley. Now a introduction to Derek DeVries. Derek DeVries is the class of '93 and is the campus business leader for the Berkeley Space Center and Regent Emeritus of the University of California. Over 20 years as an attorney and capital markets executive, he joined UC Berkeley in 2018 to focus on strategic campus initiatives. He also advised early-stage companies and venture capital firms. He has served on numerous educational and nonprofit boards, including the UC Board of Regents, the Cal Alumni Association, and the UC Berkeley Foundation. He is also a Berkeley Fellow. So please welcome Derek DeVries.
So I'm going to admit something up front. I've got a timer because we apparently have a football game right after this. So I'm going to beg your forgiveness, and I'm going to shorten this lecture so that many of us have, including me, have time to get up there for kickoff. So I hope you appreciate that. It is really absolutely my pleasure to be here today. I want to recognize that we all sit on a lonely land. This is far too much information for me to read out loud, but we do want to acknowledge this important point. So this is going to be a little bit visually intensive, but I want to start you out with this.
Three, two, one. Main engine start, ignition, and liftoff.
It looks like science fiction, right? That's actually a mission to Mars that is being managed out of the Space Sciences Laboratory here at UC Berkeley. It is incredible to think of where we've come from the 1960s, from the mission to Moon, to where we are today, which is planning active missions to Mars, to the moons of Europa and Titan and beyond. So it's exciting that that mission right there, which is by Blue Origin and staffed by Rocket Labs, is actually going to be operated, mission controlled, and managed by UC Berkeley Space Sciences Laboratory. And if you don't know about SSL, it sits right on the hill. It's that big green ugly building, and there's an awesome building behind it. And it's filled with scientists who are working on really exciting projects that are related to aerospace. I'm going to tell you a story because I'm a little bit old, which was I was walking the halls of SSL, and I actually accidentally ran into a person who had their hands like full of stuff. And it was almost like I had school books and she had school books, and we just went into each other and we landed on the floor. And I profusely apologized. And I said, I'm so sorry, I didn't mean to do this. And I said, but what do you do? And she said, oh, well, and then her eyes lit up and she was no longer angry at me. And she said, I'm actually working on instrumentation for life on a mission that's going to be launching in 2030. It's called the Dragonfly mission. And I said, okay, great. She goes, yeah, I'm building the instruments that's going to detect whether or not there's life on that moon. And to me, that was just incredibly exciting because, first of all, I'm a space nerd. I grew up watching Star Trek. I'm a Trekker, not a Trekkie, a Trekker. So now you know I'm telling you the truth. And she just started and lit up about her research. And that SSL is just one of the gifts that the campus has. It receives over $70 million of funding from NASA, not just NASA Ames, which we're going to talk about, but NASA Directorate. And it competes and it wins for all these missions that are going and exploring our universe. So I'm going to get into that in a second. So aerospace at Berkeley, why the Berkeley Space Center? The answer is it's already here. So just digging in a little bit more about SSL and all those scientists on the Hill, these are some of the missions that they are participating in. Escapade was the one that I just mentioned and I showed the video about. Padre, COSI is there as well. But these are just incredible opportunities for not only our faculty and our scientists and our principal investigators to work on these things, but our students. And our students are incredible. Did you know that we did not have an aerospace engineering degree at UC Berkeley? Instead, what we were doing was we were sending these incredible mechanical engineers, the #1 engineering school on the planet, and we're sending them to MIT, Georgia Tech, Nebraska, these incredible programs, but they couldn't advance their careers in aerospace at Berkeley. But even when we didn't have one, we were still number 14 in the country for aerospace engineering. So even without offering a degree, we were number 14. So we aim to be #1 because we just launched the aerospace engineering degree, and they have their 3rd cohort now at Berkeley studying. So those first students who joined and were aerospace engineering, the first cohort, 40 students, represented the top 1% of the engineering program at Berkeley. So congratulations to those students. And you know, if they're the top 1% of engineering students at Berkeley, they're the top 0.0001% of engineering students in the United States. And they're self-organized in incredible ways. You see a picture here of the STAR, which is the rocketry club. They're throwing rockets up in the air at the Richmond Field Station and elsewhere. There's several hundred students involved in that, cross-disciplinary. They're physics majors, chemistry majors, mech majors, some L&S students as well. We have New Space at Berkeley. These are also cross-disciplinary students that are focused on venture capital and starting their own companies in aerospace, and really just incredible. They brought in like key market speakers at a conference. I was one, but I wasn't really why people were there. They were there to see the founder of Planet Labs, which is Earth observation company, just an incredible company that takes a picture of the entire planet every single day at 10 a.m. So we know what the changing conditions of the planet are. So they brought in the founder. It was an incredible speaker, incredible conference of 600 students. And then we have STAC, which is Space Technologies at Cal. Again, a cross-disciplinary group of students who actually propose missions to go onto the International Space Station. We have undergraduates who have science experiments on the ISS, and they're self-organized. So I want to talk, and I'm stealing some slides from our next speaker, Darren Cook, who is our interim chief innovation officer, who's here in the audience today. I'm stealing his slides today because I think it's really, really important to precursor what we're doing with the Berkeley Space Center because of what has happened in the last 20 years. This is what the I&E ecosystem looked like in 2000. This is venture capital. These are new emerging companies. And this is the type of support that the campus offered. 2005, you can see we're starting to generate new programs, such as QB3, which is our life sciences center that is in cooperation with UCSF. You can start seeing that there's a little bit more venture capital starting to circle the system, but it really starts to get goosed up in 2010. These slides are available online, by the way, in case you want to see them. They're at begin.berkeley.edu or inde.berkeley.edu. So these slides represent the growth of our venture capital and entrepreneurial ecosystem. 2015, you can really see the engine starting to percolate. You can really start seeing some incredible programs. The Citrus Foundry is on here. Berkeley Skydeck, which is our principal accelerator on campus, is also on here. But guess what? This is what it looks like today. And it keeps growing. New programs are being generated every single day. Everything from the very beginning of getting programs out of the lab through NSF funding, I-Corps funding, run essentially by Rhonda Schrader, who is with the business school, to the Citrus Foundry with Ron Zakai running that program, to Berkeley Skydeck, and run by Carolyn Winnett and Sybil Chen and Taylor Marcus. We've got some really incredible innovation leaders on campus. We meet as a council every month. There's over 80 of us who join that to run all these programs because it's a bit of a spider web. The path to being an entrepreneur on campus starts from the beginning stages of the students all the way to alumni who found companies, and helping them navigate the system is our job. So what we're trying to do is identify a much more linear path for entrepreneurs where they start in the labs. Maybe they're an undergraduate or a postdoc working on some principal technology. And then they move into the Citrus Foundry, which I mentioned before, which is our incubator, where we incubate those babies. And then we push them into our accelerators, not just Skydeck, but there's other accelerators on campus. We have also the Baker, I'll get into that, the Baker Bioingenuity Hub. But all of this ecosystem is just really bolstering. And what does it produce? It produces this. We are the #1 public university, not just public, any university for undergraduate founded companies. And we crush the competition. I'm not even gonna say who #2 is. We have examples on campus of buildings, such as the Baker Bioingenuity Hub, where Darren also runs the Life Sciences Entrepreneurship Program. We have the Citrus Foundry, which I mentioned, which is part of the Center for Information Technology and Research in the Interest of Society. Say that 5 times fast, Citrus. The Foundry is where we build and incubate those small companies. We have coming online the Baker Climate Ingenuity Hub. So that will be on the corner of Oxford and University. This is going to be an entire building devoted to climate change. And then we have Berkeley Skydeck, which is our #1 accelerator on campus, along with many others. And then we get to scale. So scale means size. We have to, because we're out of room on our campus, grow beyond our physical boundaries. And so what did we do? Well, several years ago, we started looking in partnership with NASA Ames. Now, you can see at the top of the screen, UC Berkeley, and NASA Ames is one of the directorates of the NASA system, and it is in Mountain View. That is 47 miles. Or as I would say, 45 minutes if you drive fast, or 4 days if you hit traffic on 880. But so NASA Ames reached out to us several years ago, and I started taking a look at this project, and they said, we've got this land, it's been reserved for academic purposes. And we said, well, wait a second, we've got like billions of dollars of deferred maintenance. We have our own needs on our principal campus. But it was really enticing because if you look at this, if you look at where this site is, it is in the heart of Silicon Valley. If I told you plant a flag on Silicon Valley, some of you would plant it at Meta, some of you would plant it on the Apple Ring, some of you would do it at the Google campus, the Googleplex, and some of you would put it somewhere else, and I don't know, maybe the home where HP started in the garage. But if you look at the physical center of Silicon Valley, it's NASA Ames. It is the proverbial hole in the donut. And of course, it is completely surrounded by tech. All those companies that I mentioned and others. Hundreds and thousands of people who have PhDs who are working on new technology. And so does it make sense for Berkeley to plant as the flagship university of the University of California system something in the heart of Silicon Valley, 7 miles away from that other campus that I won't mention? Yeah, it does. It made a lot of sense. NASA Ames itself is just really enticing because they have what's called the private side and the public side. Our parcel is on the public side, and again, it's that triangle. It's obvious. It's the blue and gold thing. That's our parcel. It sits 100 yards away from Hangar 1, the iconic structure down there, which will live again and is being repurposed and also reskinned. NASA Ames has some incredible assets. They have the largest wind tunnel in the world. They have extreme temperature environments. They have the light source, and they have astrobiology labs. The assets in the private side of that fence are incredibly enticing for us to take a look at. But if so, another video, this is what we're building. is 16 feet tall. I have to admit, I get a little choked up when I see this video because I've been working on this project for 6 years, and when I first saw this video, I kind of got, I was a little embarrassed, I was a little red in the face, and I was like, oh man. And then I looked over at my counterpart from NASA Ames, and she was crying. She just get it, because this has been a dream of NASA Ames to have a university at NASA Ames for well over 20 years. I can't imagine what 20 years feels like. I know how long it took to get 6 years. But it's just incredible to see this vision take place. But again, I want to share, why are we doing that, and how are we building it, and what's there? It's 2 million square feet of space, of occupiable space. And if you need an analogy, that is 2 Salesforce towers. We're going to chop that up, gently lay it on the ground, spread it out over 36 acres, and we're building R&D facilities, we're building conference center, housing. We're creating an innovation hub, and mostly actually for private industry. So the way that the financial model works, which I'm not going to get into too deeply here today, is we're not using any public money for this. No public funds are being used. We have essentially contributed the ground lease that we signed with NASA to a joint venture that sits outside of the university, and in partnership with a developer, we're getting third-party capital to build this new campus. And that means a lot of private industry will be there. And for every private industry tenant, the university wants to be there side by side with them. Yes, the university will be there in absolute force. We intend to have our students, our faculty, and our researchers embedded in their own buildings and with private industry partners that fit that vertical. So here's the schematic, and I promise I won't read these slides. But if you just look at the visual, what we're trying to do is create an innovation ecosystem that anybody can participate in. So if you look at the companies that we've identified, this is one particularly focused on aerospace. We put it together with the rich resources of the University of California, and also the NASA, and we're the front doors, by the way. It's not just NASA Ames. This is Goddard, Johnson, JPL, and for UC, it's Santa Cruz, Merced, Davis, all of our system assets. You put all of them together, and we think and know that we will create these incredible outcomes. We'll have early stage companies there, we'll have legacy companies there that will focus on changing the world, solving existential questions and crises, and we're gonna all do it at NASA Ames. So our focus will be, for the next 3 years, building this site. And so you're saying, okay, well, this feels really far off in the future. You're not even gonna probably break ground for another 2 years. But what are we doing today? We're building the academic research programs that will eventually connect our main campus to NASA Ames. And so I want to give you an example of the aviation cluster. Right now, commercial companies are really heavily focused on solving transportation issues. Electric vertical takeoff and landing companies, eVTOLs, are now getting flight clearance from the FAA. So we have companies like Joby and Elroy Air and Wisk that are resident already in the Bay Area that have already partnered with NASA Ames, have partnered with our Institute of Transportation Studies and with Citrus, which has an aviation wing, and they're focused on solving the problems of electrification, transportation, and I want to make one point about this. So at any given time over the United States, there are 5,000 objects flying around, which requires the FAA to manage that. Now, imagine with drone technology, 200,000 objects flying around in any given flight system. So who's going to solve that air traffic nightmare? It's NASA Ames. Remember, the second A is aeronautics in NASA, which already has flight simulators down there, and Berkeley with its incredible data computing facilities, quantum computing, high performance computing facilities. It's gonna take those kind of breakthroughs in technology to enable autonomous airless taxis and drone technology to become a thing. And one thing that we've really wanted to do was inspire our students to participate in the Berkeley Space Center. And because the associate provost of the Berkeley Space Center is also the director of Citrus, he was able to channel the students in one direction. And I'm going to go ahead and I have to switch because this is an embedded video. But let me go ahead and describe how we're bringing students to the problem today that will eventually occupy the Berkeley Space Center.
The Citrus Aviation Prize dares student teams to dream big, crafting a sustainable vision for the future of advanced air mobility. From fully autonomous long-distance UAV flights to innovative air taxi designs that could link UC campuses, this competition inspires groundbreaking ideas. Building off the conceptual design generated the previous year, this year's competition continues this exciting multi-year journey where student teams will develop each of the system's air operations simulation software for a mobility network envisioned for the University of California. Their work will pave the way for sustainable, efficient travel between UC campuses linked by Citrus, ushering in a new era of connectivity. The prize will challenge teams to explore electric vertical takeoff and landing solutions around Moffett Field, enhancing safety.
Frankly, that was actually where I was going to stop the video anyway, so I'm glad. But you get the idea. The Aviation Prize is a way to get our students engaged in designing what does an eVTOL landing site look like if we put it at Moffett, and where is the most optimal landing spot at UC Berkeley? What about Merced? What about Davis? And so we had competitions and teams from each one of those campuses focused, and we're now in the second year of the Aviation Prize. The first one was about flight pathing and how do you move between all of those different campuses, and the next one is, okay, where do we actually put this thing? And what does the vehicle start to look like? And we have industry experts participating as judges for this Aviation Prize. So it's just really exciting because these students are just given incredible greenfield over how to think about it. And Alexander Bryan, who's the associate provost, and I have the pleasure of mentoring and coaching and judging these teams. And what's exciting about it is, like I said, okay, so where are we going to put an eVTOL landing site on the Berkeley campus? I mean, forget all the community. We don't have to worry about the community backlash that we might receive, but let's think big, and let's think about being the first university in the world that has eVTOLs going up from its campus over and down to NASA Ames. So partially solving that transportation problem that I was talking about earlier. I want to focus in my last 10 minutes, and then we're going to open it up for a few questions about the startups that are coming out of our ecosystem. So with programs like Skydeck and the Citrus Foundry and all the other entrepreneurship programs that we have, Haas, Launch, things like that, we have actual aerospace companies coming out of our ecosystem. Space Kinetic was founded a couple of years ago by an MBA graduate from Haas and a Master of Science student from the College of Engineering. And what Space Kinetic is doing is it's moving objects from low Earth orbit to higher points of orbit using low energy solutions, hence the name kinetic. So their whole opportunity is one of the largest energy transfers and the cost of energy that happens is by moving things up into a higher orbit. So if you can get things to LOE, low Earth orbit, LEO, then you can actually push, pull, or use some other mechanism to get them to a higher orbit, like middle Earth orbit, and then or a higher orbit, like where the ISS is, or even beyond. So they use what can best be described as a slingshot to take objects from where they land in low Earth orbit, like there's a payload that goes up and there might be 10 objects, and then they'll slingshot it into its proper trajectory, proper orbit. So by using kinetic energy. Another way to think about it is a trebuchet in space. So I love that's on my bingo word, trebuchet. So it's like those medieval objects, and it just throws these things. And because we have a member of one of our graduates who knows how to, with pinpoint accuracy, throw those objects up into their orbit, they've already got a contract with the US government. And they're 3 years old, and it's 2 guys. And it's just an amazing company that's come about our ecosystem. Skyloom went through our Skydeck Accelerator. It's actually a company from South America, and they're building new constellations of satellites in space, different ways to communicate. And I kind of want to pause here because one thing that's driving space and space exploration is this is not only the next or the future frontier or visionary, but it's also contested space. So if you go back to the 80s when the treaty for the moon was signed, there were 5 countries that did not sign that treaty that said they weren't going to commercialize the moon. And you can probably name which countries said they weren't going to sign on to that treaty. The United States, the Soviet Union, as it existed at the time, China, India, which has just started landing objects on the moon, and France for some reason, I don't know, because they're French. But you can imagine, look who are the actors that are in space most actively right now. It's those countries. It's the United States, it's Russia, it's China, it's India. And so they have not foregone the opportunity that there is a lot out there. There are a lot of resources that we need to grab onto to even further our mission beyond our atmosphere. And there's also a lot of opportunity to hurt one another. So there are companies out there that are designed for resilience, for security and safety, to protect all of those satellites that we rely upon for everyday things. Everything that your phone does today relies on satellites to push information to you instantaneously. Imagine if that was disrupted. Imagine if GPS wasn't enabled. Imagine if the internet didn't work. That could actually just completely, imagine our financial markets would not work because information is transferred using satellite communications. So space is contested. And so you will continue to see these governments invest heavy, heavy amounts into space technology. And that is one of the reasons why innovation out of our public universities going out of these labs is really important and spurring a ton of new companies in entrepreneurship, because we have to find ways to protect what we have up there. Not only just put it up there, but protect it when it is there. Speaking of protection, I love using squishy robotics as an example, because it really is like kind of what the Berkeley Space Center is all about. This is a company that was spurred out of NASA Ames, and it was a member of our engineering faculty who had that technology. She commercialized the IP and formed this company. So it was all those verticals I talked about. It was government, NASA, academia, UC Berkeley, and private industry once she started her company called Squishy Robotics. Squishy Robotics went through the Skydeck Accelerator. So you can see how they're touching all these parts of the innovation ecosystem. And what they do is there are places they studied it for Mars, but then they put a domestic application or terrestrial, not extraterrestrial, but terrestrial application to their company. But this robot works in extreme environments. So think about wildfires. You don't want to put firefighters in a place where there might be toxic chemicals, there might be fumes that they just can't breathe, or the smoke is so, you need to know what's there. What are they going to be exposed to? So not forgetting drones that can now put out those fires. But their robot drops in, just like that second grade experiment where you had the egg, and you had to build a structure around the egg and then drop it from a height, and hope that the egg did not break. I mean, I think most everybody had to do that when they were an elementary school student. This one does it too. So Squishy Robotics drops into a hazardous environment, measures it, tests it, understands what the environment looks like, and understands what the emergency response should be. That's the end of my talk, but I wanted to take a couple of questions from the audience, and then I want to get you to that football game. And if you ask a question, I've got some really cool 3D laser printer coasters. Okay, great. And I'll repeat the question if it's not, but please.
Hi, thank you very much for an informative presentation. This is, according to all the news, a $2 billion with a B dollar project. How far are you along in funding, and based on that, do you anticipate a phased opening or a phased development of the project? And the second part to the question is, if that's the case, will the UC Berkeley students get to be there at the beginning, at the ground level, as sort of preferred customers of the site? Thank you.
Yeah, no, that's a really great question. She rightly identified that this is a $2 billion project. built by private capital. So we have a joint venture partner named SKS Partners, which is responsible for finding that capital and building the site. What we first need to do, and we're in early stage talks right now, is find an anchor tenant. Now imagine a company that would be attracted to being at NASA Ames. There's a federal airfield right there. There's NASA scientists. What unlocks that potential is UC Berkeley. So we absolutely fully intend our students to be on site along with our faculty and researchers and collaborate and cohabitate with companies that are coming into that site during the first phase. So this is a phased project. The financial model projects this out for 12 to 15 years. We might not be done building that site in that time frame, but we built a very conservative model to allow us to build phase after phase as we grow the site. Now, if we have early interest and a number of companies come at us and say, we want to build this site, we have the flexibility to collapse all those phases and complete it within 5 years. But it's more realistic and it's more prudent and conservative to build a financial model that projects it to go out on a much further basis. Speaking about the students, the first cohort of the students that were in the aerospace engineering degree program that I mentioned, there was 40 of them. Half of them became interns at NASA Ames. It's that first summer. So it really has produced an engine of students already going down to NASA and to other tech companies. And you get a prize. Thank you.
Hello, I was wondering, you had mentioned about this space program. I actually was in NASA when they started that. I actually worked at NASA and we actually had to relocate a bunch of burrowing owls from that space.
Yeah.
But my interest is for students that are not necessarily in engineering or the Haas business. What are the opportunities for students that are in other fields like biology, math, other STEM fields to get involved in this program if they're majoring not in engineering or business?
Yeah, when we built this program, it became a chancellor's initiative. It wasn't a College of Engineering initiative for explicitly that purpose, to identify other opportunities across all colleges, units, and research units on campus. We now have what's called a faculty steering committee, which has disciplines from L&S, from math, from physics, from public policy, and business. The School of Business is participating in that faculty steering committee specifically for the purpose of identifying opportunities for students who are not just STEM, but non-STEM. So in our last faculty steering committee, we actually had a member of our films and arts faculty talking about 3D interpretive dance in space. Like, how do you do it with no gravity? And it was really cool to think about, how do we get symposiums of art-based culture and reach out? How do we speak to the indigenous community down there and really build something that is available for everyone? Well, now, specifically on biology, one of the key clusters, NASA Ames has 8 clusters that are focused on is astrobiology and extreme environments. So that's not just an engineering problem, that's a biology problem, that's a physics, chemistry problem. How do we live and how do we send people to Mars? So creating habitats that people can live in on the moon, launch themselves to Mars, keep them safe from radiation. Psychology, how do you get people 2 years? So our College of the neurobiologists are participating in that exercise. So it really is meant to be a fulsome, wholesome participation, not forced. We want to naturally attract people to the program. Yep.
Is it on the roadmap to explore like breakthrough propulsion technologies like nuclear, fission, fusion, things like that to kind of accelerate progress?
Absolutely. So as you might know, our College of Engineering includes one of the best nuclear engineering faculty on the planet. So breakthrough technology, not only hypersonics and electrification, but also nuclear and other propulsion is absolutely on the roadmap to be studied first here within our labs. But once labs are created down there, you can see that there will be a natural migration and synergy. So one thing that we've done is we've started pulling together technical symposiums with NASA Ames. And we started with advanced aviation. That was really amazing. We brought our faculty and scientists, and we all went down to NASA Ames, and they pulled their scientists in, and we had them solve or look for opportunities to do further research, the next generation of research. But we first had to understand what we were both working on. right? And so everybody sort of just went, open kimono, I'm working on this, you seem to be working on that, let's talk. So electrification of vehicles, transportation management was another vertical. So we will absolutely get to those other verticals. The next one is extreme environments. So I already talked a little bit about that. Like how do we keep people alive as they're going on these multi-year missions and actually living in an environment? You know, it can't be just Matt Damon on Mars. It's going to be us. So we learned a lot from the Martian, though.
I'm excited about the technology and the rapid advancements of moving machines and materials into space, but I also have concerns about maybe failed pieces or materials and the impact that waste or random things floating around in space. And so I wonder if the technology and the research is also moving at the same pace to clean up, if you will, or help create sustainable technology and advancements.
Yeah, the question was more about, and I'm just going to paraphrase it if you don't mind. There's a lot of debris up in space already. You know, there's a lot of crud out there, and we even had a near miss with ISS that was being hit by an object that, you know, was about an inch big, and that could actually bring down a space station. So we have to be able to track objects that are up in space and remove them. So there are a number of what we call bus companies that are thinking about how do you push things out of orbit when they're deprecated and they're not on a path that circles down and just naturally gets destroyed by the Earth's atmosphere. And then how do you actually identify and remove them because they're hazardous. And also the number of things that are already in low Earth orbit are affecting our ability to actually go to the ISS and open those windows of transportation to Mars. Because if something's in your way, you can't exactly move it. You have to actually identify it and fight a path that's either around it or, you know, slightly askew to it. So that is an actual problem. And there are a number of legacy companies and startups that are actually working on this. I can think of Space Kinetic is one of them. So they're not only like what you can sling into space, you can also take out. So you can actually knock an object out of space. There's another company that's just coming on board called SkyMapper. That's being launched by the chief scientist of SETI. SkyMapper is actually just using Earth observation to know what's up there. So there's a lot of dark objects up in space right now, and either that's for adversarial purposes or just because somebody left it behind. But with sky mapping technology, you can actually take a picture from below, up above, and absolutely identify what's up there in order to remove it. So I assure you there are companies that are working on this problem. I also want to touch upon something about social responsibility. One of the things that we do when we take a company that might be aerospace oriented through one of our incubator or accelerator programs is we say, what's your terrestrial application? It's great that you want to mine on the moon. It's wonderful, but how are you going to get to the moon? Is somebody going to beat you there? And what are you going to do while you wait for that bus to take you to the moon? So we have a new company coming into Skydeck, which I'm advising, called OR. And OR is all about mining the moon. That's their moonshot. It's great. Focus on the vision of the moonshot, but tell me what your terrestrial application is. OR uses muon radiation technology to understand what materials are below the surface, so you don't have to bore holes and create, you know, massive waste, you know, destroy our planet by finding out what's underneath. So they use this solar radiation measuring technology to understand what is underneath the surface before you kind of like dig it up. So we're thinking about sustainability application. And we also know that especially with respect to climate change, if we're studying a really, really hard problem, like extreme environments, we know that same technology can help solve problems that we have here on Earth. So we're always looking up and down. Rocket Labs is really good at that. You know, they're measuring and then taking the picture. They now have new satellites out there that are doing methane detection. So it's not just mapping the Earth, they can actually show you who are producing the largest sources of methane. And they show exactly where it is and hold those countries to their feet for emissions by just being transparent and showing where that information exists. I think we have time for one more question.
Yeah, hi. I'm a current undergrad in the aerospace program, actually. And
Did you like all the shout outs?
I did like all the shout outs. I'm not in class of 26, though.
Yeah, it's great.
But my question is, what is the plan for undergrad involvement in Berkeley Space Center? Like, is it research? Is it classes? Is it internships?
Yeah, you know, we've already started with internships for sure. And one thing that we really think is an opportunity for undergraduates is actually just taking classes there. So we do envision some academic site. We do envision that sometime in that phases of the project, maybe a little bit later in the project. So apologies to current undergrads, it's probably not going to happen for you. But there is a future where undergraduates will be going back and forth, taking classes at NASA Ames with resident faculty who are sitting at NASA Ames. Another thing that we're really working with NASA Ames on is how do we get sort of like the JPL environment where they can be dual appointed. Right now, NASA scientists can't be also members of our teaching faculty, but it would be great if we could do a dual appointment so that NASA scientists can also be our teaching faculty. And so those are some of the things we're trying to unlock, which will benefit undergrads. Okay, I promised you all, for those of you who like football, so I know not everyone does, that I would end a little bit early. So thank you for your time. I really appreciate it. Please go to spacecenter.berkeley.edu. Thanks.